Hi and welcome to another video. This time we're going to look at the benefits of using SOHCAHTOA for finding missing sides and angles in trigonometry versus the sine rule. Each have their merits and we'll have a look at the benefits of both. So if you're looking initially at using SOHCAHTOA, and check out my other video on finding angles using SOHCAHTOA and trigonometry. It has to have a 90-degree angle, so it has to be a right angle triangle. Otherwise we cannot use SOHCAHTOA. They will have the angle that they give you, namely called theta, and then you're going to find a missing side or the missing angle. So let's for instance say we're going to say directly opposite the right angle is my hypotenuse. Opposite the given angle that they give me is the opposite side, and the one that runs alongside is the adjacent. So using them sides to find SOHCAHTOA, we'll be able to find the missing side or the missing angle, depends on what they're looking for. The benefit of the sine rule over trigonometry is if I've got a right angle triangle, I can still label that as my angle A to my side A, my angle B to my side B, my angle C to my side C. And on that one we are looking A divided by sine A is equal to B divided by sine B, which is equal to C divided by sine C. So I'm looking to say the angle, whatever the value of the angle is, if I can find the sine of it and then divide that into the length of my given side, I would be able to find any angle. Now I can do that if that's a right angle triangle. I'm still going to be able to do that, and that will work if that triangle is not a right angle triangle. Obviously my sides are just going to change along with that, but I can use that for any triangle I like, whether it's a right angle triangle or if it's indeed not a right angle triangle. So let's look into it and see where we go. So if I'm looking at doing this one, and we'll have a look at doing it, solving it both ways. So we know that's the hypotenuse, we know that over here the y is going to give me my opposite, and we know the bottom side there is a adjacent. So I don't know anything about the hypotenuse, they don't want me to find it. So if I'm thinking of using SOHCAHTOA, I don't know the hypotenuse, they don't want me to find it, so I'm going to be using TOA. So writing that out then, the tan of the angle is going to give me equal to opposite over adjacent. Now remembering back to the triangles, if you're used to using the triangles, I've got tan of the angle, opposite, adjacent. So remember, if I want to find the angle, I'm going to do opposite divided by adjacent. In this case, it's the opposite they want me to find. So if I cover up the opposite, then I'm going to do tan of the angle multiplied by the adjacent. So let's write in what I know. The tan of 38 multiplied by the adjacent, which is 9, and that's going to give me y. So if I type into the calculator, so tan of 38 multiplied by 9 equals 7.0315 and a load of odd months. Now it wants it to one decimal place, So I'm going to round it at that point there. The 3 is going to round it down, so it would be 7.0 to 1 decimal place, and I'm in centimeters. So 7.0 centimeters to 1 decimal place. Now, because they give me that angle there, I'm going to call that angle A. So I'm always going to say the angle that they give me, I'm going to call angle A. Okay. So that means that side is going to give me little a. I've got the second angle, which is the 90 degrees. Let's call that angle B. That's going to be little b. Let's call that angle C, and that's going to give me little c. Okay. Now, to be able to calculate this, I need to know the two things on the same side. Now, I don't know B. Right. So while I do know the 90 degrees, I can't use that side because that angle, because I don't know the B side, the hypotenuse. But what I can do is, if I know that's 90 degrees, okay, what I can do is I can say, well, actually, if I do 90 plus 38, that's going to give me 128. And then if I do 180, take away 128, that's going to give me 52. So I know that this side here, this angle here, has to be 52. So if I know that's 52, and I know that side's 9, I'd be able to use that in this sum. So a little bit of math work to do to use the sine rule at the start. So let's now calculate it. So I'm going to say we've got sine A, sine C, and side C. So we know that A divided by sine A is equal to C divided by sine C. And all we're going to do is we're going to substitute the values that we've got in here. My sine C is 52. So I've got the sin of 52 is the denominator, and the numerator of that fraction is going to give me 9. Is going to be equal to A, which is y, divided by sin 38. Okay. Now remember, if I'm solving for y and I want to find y, I need to take what's on the denominator of the fraction, move it the other side, and multiply it. So I will end up with 9 sin 52 multiplied by sin 38. And that's what I'm going to type into the calculator. So fraction key, 9 divided by sin 52. Always remember to close the bracket and then tab to the right, multiplied by sin 38, and again close the bracket. And that's going to give me 7.0315 and a load of oddments. And I'm back to the same thing where I'm going to round that to 1 decimal place. So my answer of y is going to give me 7.0 to 1 decimal place. Okay, so whether you want to use sine, the sine rule, and that can be used for any triangle to find the side, or you can use SOHCAHTOA, but that's relying on you picking the right ratio. Okay, so here's the next one. Pause the video, use whichever one you want to use, whether you want to use SOHCAHTOA or whether you want to use the sine rule. Okay, and then see how you get on. Okay, so let's see how we did. Now, if we did SOHCAHTOA route, okay, we're going to hypotenuse, opposite, adjacent. Okay, this time we don't need the adjacent, so therefore we're only going to use sin. So sin 25 equals y divided by 12. Multiply through by the 12, both sides. So sin 25 times 12 gives me 5.07, and to 1 decimal place, round that up, gives me 5.1 centimeters. If I'm looking at using the sine rule, Okay, labeling it up this time A to A, B to B, C to C. Okay, and this one we've got the hypotenuse that we're using, which is opposite my 90 degrees. So I don't need to find the third angle this time. All I'm going to do is I'm going to literally just use the B. So A divided by sin A equals B divided by sin B. Substitute the values in. A is y so divided by sin 25 equals 12 divided by sin of 90. Okay, and then calculating that out here, remember we're going to multiply through by the sin 25. Okay, and I end up with 12 divided by sin 90 times sin 25. Okay, and that's going to give me the same answer, 5.1. Okay, hopefully that makes sense. And just choose whichever ratio you want, whether you want to use SOHCAHTOA or whether you want to use Sine Rule. So let's have a look. If I've got an angle, exactly the same process. Okay, if I'm looking on this one to use the Sine Rule, okay, I'm going to say, well, that's my A, this is my side A, that's my B, okay, which is opposite my angle B. Okay, now I don't know this side, so I can't use the 90, and I don't know what that angle is. Okay, so on this one, if I'm looking to find the other angle, I'm at a bit of a loss to be able to do that. What I would have to do now first, because I know this angle is 90, okay, and we can't find that angle out until we do this calculation. Okay, what I'd have to do is I'd have to do, well, this is my A squared plus B squared equals C squared. So A squared is 36, 12 squared, B squared is going to give me 144, so that's going to give me 180. That's going to equal the C squared. Okay, what I would have to do is square root both sides, so I know that C is going to equal the square root of 180. So I know that's 90 degrees. That's going to be my C. This is going to be my small c. So I'm now going to use what I've calculated here to be able to find that angle. So I'm going to put A, which is 6, divided by sin of A, don't know what that would be, is going to be equal to this side, which I know is the square root of 180, divided by sin of 90. Okay, I want the sin A on its own. Okay, so I need to move the whole of this part of the fraction over this side and put the sin A over the other side. So I'm timesing through by sin A, times through by sin A, eliminates it from this side and leaves 6 on its own. So times through by sin A. Okay, and my next step is I'm going to divide by the whole part of the right hand side of that equation. So I'm going to divide through by 6 divided by square root 180 over sin 90. Okay, that would give me sin of A. If I want A on its own, okay, what I'm going to do is I'm going to do the inversion of the sign. Okay, so if I do sin to the -1, that will cancel that and just give me my angle. So I'm going to do the whole of that to the sin -1. Now, while it's not mathematically correct to have a fraction in the denominator of a fraction, what your calculator will allow you to do is to type it in exactly as it is there. So I could put shift sin to give me my sin minus 1, opens a bracket, put your fraction key and do 6, tab down, fraction key again, and I'm going to do the square root of 180, tab down, sine of 90, close bracket, tab to the right, and make sure you close the big bracket as well. Okay, and your answer to that is going to be that my A is going to equal 26.565. So if I'm rounding that to one decimal place, 26.6 degrees. So 26.6 degrees. So if we're looking to do this one using SOHCAHTOA, finding the missing angle, okay, so hypotenuse, okay, that's going to give me the opposite and the adjacent. I don't know the hypotenuse, so I know O and A. So again, when you get quite confident with this, you can easily see that we're going to use TOA again. So we know we're using tan of y, that's what we want to find, and I've got 6 over 12, so I can type that in as tan y, we don't know what y is, equals 6 divided by 12, and I'm going to need to get rid of the tan by doing tan minus 1, which cancels the tan to leave me y. So I'm going to give me tan minus 1 of 6 over 12. Okay. So again, if I type that into the calculator, tan shift tan 6 divided by 12. Remember, we need to then tab to the right and close the bracket, and that's going to give me 26.565, and again one decimal place, 26.6 degrees. So on that one you can see that the finding the missing angle would maybe be easier using SOHCAHTOA if you're confident with that, because there is quite a lot more work to do having to use Pythagoras to find the missing side, the square root of 180, using the sine rule. Okay, so there's pros and cons for both. Okay, have a go at the next one, finding this missing angle. Okay, the sides are exactly the same that we're trying to find, so you will have to use Pythagoras if you want to use the sine rule on this one. Okay, so pause the video, see how you get on. Okay, so let's see how we got on. Okay, so we've got SOHCAHTOA root, tan minus 1 of 7 divided by 14 gives me 26.6, and you can see 7 divided by 14 would give me 0.5, so I've got the same thing as 6 divided by 12 was 0.5, so it'd be the same size angle on this one. Okay, whereas if I had to do it the sine rule to try and find the angle, okay, then it's going to be quite a bit more in depth. Doing Pythagoras, I find out that the value of c is the root of 245. Okay, substituting that into the value of 7 over sine of y equals root 245 divided by sine of 90. Remember, I've got to swap the sides. Okay, so I'm timesing through by sine y and then dividing through by what's on the right hand side of the equation. So I end up with 7 divided by root 245 divided by sine of 90, okay, which is going to give me sine of y. Then I'm going to do sine minus 1 on both sides, so sine minus 1 of 7 divided by root 245 over sine 90 is going to give me 26.6 to 1 decimal place. Now, one thing I will say at this point is when you're calculating this, because you're using sine 90 equals 1. So I could make sure if I'm doing that, if I'm writing that, if I don't want to show it with the sine 90 in the denominator of the fraction, if I just did what the denominator is going to equal, 245 root divide by sine 90, and that's dividing by 1 because sine 90 equals 1, is no different than saying 245 over 1, and anything divided by 1 is itself. Okay, so whenever I'm doing this and I'm dividing through by sine 90, it's like saying I'm dividing through by 1. Okay, so let's just look at the workings for that. Remember I started off with 7 sine of y equals root 245 divided by sine 90. If I simplify that to being 1, okay, I can just say it's the numerator only. So 7 over sine of y equals root 245. And then if I want to swap those over, 7 divided by root 245 is going to give me sine y. And remember, to get sine y, to get y on its own, I'm going to do sine minus 1 to cancel that. So I'm going to type into my calculator sin minus 1. So it gives me something a little bit less to type in. So I'm going to shift sin fraction key, and then this time I'm just going to do 7 tab down root 245 and then press equals, and that gives me the same answer. Okay, so understanding that sine 90 is equating to 1 would make my equation look a lot simpler when it gets to this sort of stage. Okay, so I'm able to make that look a lot nicer than we did obviously in the last one when we're leaving it all as a fraction. Like I say, there is no hard and fast rule as to which one is best. It just depends on which one you find easier for you to be able to calculate. Sometimes that may be SOHCAHTOA, sometimes it may be using Sine Rule. I think what I've found is, as a rule of thumb, if I'm finding a missing side, okay, then sometimes it's easier to use the Sine Rule because I'm only using that one specific rule. I'm only going to use the sin ratio to be able to calculate that. If I'm finding a missing angle, I would prefer to use SOHCAHTOA because there's a lot less involvement in calculations and mathematical processes. So we've only got to pick the right formula. So let me know, just drop me a comment, which would you prefer to use when you're calculating it? Would you use SOHCAHTOA or would you use the Sine Rule? Let me know. And I'll catch you again next time.